folks. Thanks for coming. So this will be like a general talk about software vulnerabilities, CVEs, and things like that. I know that most of you know a lot about this, but I also found it useful from time to time to take a step back and go through the basics, right? So when we talk about software vulnerability, it's usually CVE, right? So we start with the CVEs, and there's a couple of things that we want to, a couple of issues that we want to solve when we talk about vulnerabilities, that we go one step at a time. And the first thing is that we want to provide a unique identifier, that we know that we are all talking about the same incident or the same vulnerability. That's where the CVE is coming from. All the famous CVE formats in the shape of the ID, year, and the number, which gives us an easy vocabulary to talk about the vulnerability. One thing I would mention here is that the year is maybe misleading, because that's the year when the vulnerability this ID was reserved, but the vulnerability for multiple reasons can be actually published later on. So if you see a CV 2023 or something, it might be a fresh one. So take a look at that. Beyond the ID, CV also defines a CV record, which provides us with only a first stepping stone into figuring out what's going on. So it's just a brief description of the vulnerability with references to further places where we can look at the affected products and advisories for this. So the CV record as itself doesn't contain too much technical information, exploitability information, or mitigation steps for this. You need to look for that at other places. Today, CV project has its own CV list GitHub, which is super useful. So that's where all the vulnerabilities eventually are submitted as different files. And it's transparent, it's version controlled, and it provides a very good source for other tools. The files are basic JSON files, and there's a JSON schema defined, which allows us to release data that I mentioned. So the basic metadata, metrics, scores that we'll talk about, and things like that. So as I said, having this kind of thing in a GitHub repository is super useful for other tools, because they can easily then ingest their data into their databases and use it. And it's also transparent. So now that we know what we are talking about, so we have identifier of the vulnerability, we need to know the next thing, how serious this thing is. And this is where things like scoring is coming to play. So basically what we want to do is to assign a numerical or more literal score to the severity, so that we know that we are talking about something that's low or very not non-important severity, to something that is critical and that needs to be looked at immediately. For that, the CVSS standard was developed practically in parallel with the CVE program, and there are different versions of the standard that evolved over years. Basically, starting with the 2.0, that's where where CVSS scoring has been more widely adopted. But today, you can see mostly 3.0 and 3.1 scores inside of the CVEs. Starting, I think, late last year, more and more vulnerabilities are starting to use the version 4 of the standard as well. And the whole point is that as the standard evolved, it became basically a little bit more precise. So the whole idea is that we can express better all the complexities that vulnerability is talking about into this single digit, right? So if you can see somewhere advisories and vulnerabilities having multiple scores with multiple versions, just because of tooling work that way. But basically, you should be going for the latest CVSS version as a score, because it should be the more precise, as we will see in the example later on. So how do we score a vulnerability, right? People defined a couple of things. So first thing is the base scoring that we'll be talking most about. The base scoring is the basic fundamental characteristics of vulnerability. But this base score can be affected by different things, basically temporal and environmental. And temporal meaning that this score can change over time, depending on the things, how the threat changes over time, but also can be different in different kind of environments. So these two things can affect the final scoring. But the base scoring, it's all basically come back to the common sense. So how severe this vulnerability is. So it depends on multiple factors. For example, attack vector, right? So do I need a physical access to the machine to be able to exploit this vulnerability, or is it exploitable over the network? That's completely two different things. Is it a very complex logic required to do that, or is it simple, right? So all these things basically have a kind of a coefficient that you can use, and then a basic math and basic formula that you can play with and come with a final score, right? So you can see examples of this at the first organization who is responsible for CVSS standard, and you can find a calculator and a lot of examples there to figure out how people come up with a particular score for a particular vulnerability, right? There were a couple of shortcomings with the current version 3 standard. Basically, people didn't use too much the temporal and environmental scores, because they were not designed good enough for folks to be able to use them easily. And coming from the like a traditional IT system, there weren't too many concepts of how to apply this to physical environments that are becoming more and more actual these days, like IoT systems or industrial control systems, health and similar, right? So that was tried to be fixed with the version 4 of the CVSS scoring, basically giving a finer granularity of the base metrics and trying to fix some of these issues and coming with a little bit improved math, which will not go into details today. But I can show you one example that's coming from the first org, and as you can see, you can get quite different scores depending on are you applying the formula for the version 3, version 4 only with the base metrics, or including also the threat metrics. So now that we have an ID, we know how serious this thing is, we need basically also another mechanism to see how to identify the whole products and the components within the products that are affected by a particular vulnerability, right? And that's a topic on its own, basically. So, but we will cover just a couple of concepts like CPEs and pearls, which Philip, who gave the previous presentation, is all about. So, CPE also coming from the older age of CVEs and was created by the NIST organization in an effort to be able to provide unique identifiers for different software operating systems and hardwares, and then help tools automate everything that we can do to match vulnerabilities to these software systems. It's a very simple schema, basically colon-separated elements, starting with CP, the version of the protocol, then the part trying to identify is it application, operating system, or hardware, and then going like how would you intuitively go to identify a software product. So a software vendor, the product name, the version of the product, and then different kind of qualifiers that can further narrow it down to a different software architecture or something like that, right? Here are a couple of examples. For example, how would you identify the Red Hat Enterprise Linux operating system and its subversion? And as you can see, I mean, in theory, you can use this schema to identify open source packages and libraries, like we have an example here of the Apache HTTP server, but it's not ideal, right? So that's why the pearls are used for that, as we will see in the minute. But currently, CPs are mainly used in SBOMs and CVs and security advisories to basically identify the whole software products, not the packages, not the libraries within it. So Perl is another attempt to basically do that for the open source world. And the idea was to define a kind of URL kind of schema just applied to this domain space, and you can see it's a very similar. So you can have your ecosystem. So GitHub, Docker, Maven, whatever you're using. So the packages are classified into those. And then instead of the vendor and the name, we have this namespace within this ecosystem. So different, for example, GitHub organization, and the name of the software library, followed by its version, and the unlimited number of qualifiers that can further on help us identify the software, right? With this, now we're coming with the concept of SBOMs and the effort to be able to provide a detailed component list of a software product or software project. I'm sure most of you are familiar with SBOMs, but it's just the idea to have a machine-readable format that we can specify all the dependencies that one software product contains, right? And in that context, as I said, like CPs are more used to define the product as a whole, and then we have pearls being able to define all the packages, open source packages used by this particular product. On top of CVE, there are also a couple of more recent efforts to provide a better vulnerability disclosure for the open source world. And one of them is the OSV, or Open Source Vulnerability Database, which help us to actually deal with disclosing vulnerabilities in a more natural way for open source products. So everything is basically based on pearls. So we are not trying to identify the whole operating system or packages. And in a similar way, like pearls, the vulnerabilities are actually combined in the different ecosystems, like we said before, like Go or NPM or Java ecosystem, and provide us to have like a non-CVE identifiers, which can be good for different ecosystems, not to be forced to go to the CVE program. The whole OSV project contains out of the two major parts. One is the OSV schema. Again, JSON schema in which we can publish OSV reports. Very similar to CVE one, and it's already very widely adopted. So, for example, GitHub security advisories are using OSV schema, the same as the Rust security. On top of the schema, there's a public service called osv.dev, which provides a service, a running database, and the API, which you can use to query basically pearls for known vulnerabilities. Also super useful for other tools to be able to call. It also allows us to query in batches and give a good results out of it about known vulnerabilities for certain software packages. So far we talk about vulnerabilities, and we said that vulnerability just describe the basic vulnerability, without any other information about remediation of that vulnerability, right? So that's what's called security advisories, which are usually published by different software vendors, right? And typically one security advisory can describe more than one vulnerability in a certain product or a product release. It will usually mention all the vulnerabilities found, but also the status of remediation of that vulnerability in that product, right? So, and those remediation can be different. Like it can be just a simple mitigation by using different kind of configuration. It can have like a hot fix for the vendor, or it needs like a full upgrade to remedy the certain vulnerability. Also, one of the very recent things is something called VEX files, or vulnerability exploitability exchange, which are usually looked at as accompanied documents to SBOMs. Very similar to, if you think about it, to security advisories, and it basically asserts that a certain SBOM or a certain product is in different state of affection of a certain vulnerability, depending on how that package is used. For example, you could have in your SBOM a Perl that has a known vulnerability, right? But maybe your code is not using that particular functionality, or it doesn't use that particular configuration. So you're basically not affected, or you're using some version that's already patched and fixed, or you simply don't know, and then that's the latest status known as under investigation. And the whole point of VEX files is to basically, cut down on the noise. I don't know who said it on one session today. It's not problem today that we have too many data. It's problem to find the good information in all the data, and the VEX file should bring us that. So basically, the VEX file should be the results of the investigation of the product security team when looking through and triaging the found vulnerabilities in a certain SBOM or a software product. So today, most of the SBOM formats, the most popular ones, the CycloneDX and SPDX, come with the support for VEX statements. So you can embed them directly into your SBOMs. But there's a VEX-specific formats like CSEF and OpenVEX that can be used to do that. So yeah, that's all I had to say today. I hope I'm at the time. Huh? So.